All right. We're going to work on dividing polynomials. This is module 9.8. You have a note sheet that says module 9.8. There also is another worksheet. It's the same exact thing, but it says 9.2. That's a typo. So if yours says 9.2, just know it's 9.8. You can scratch out, replace that with replace the 9.2 with 9.8. Okay, let's get started. On your note sheet, you're supposed to be doing this, the check. But it just so happens that the check that you're doing, I'm doing the same problem. So there's no reason why you shouldn't get this done. Okay, let's do some review. Remember, poly is a Greek term that means many, and nomial is a Latin term, nomial, make that correct, nomial is a Latin term that means term. So that means we have more than one term. If you notice here, we have 1, 2, 3. This is a trinomial. When we do these type of problems, you don't have to. But if it makes it easier as you learn it, you're going to divide each of these terms by what's in the denominator. What's in the denominator? Negative 8x. So I will have 3 separate fractions. I can break it up that way. So we're going to do that just because we're learning it. And we'll use orange. So now I'm going to have negative 64 x to the 5th, and I think I missed a term. Oh, no, that's correct. Negative 64x to the 5th divided by negative 8x. Then I'm going to have positive 32x to the 4th divided by negative 8x. Then I'm going to have negative 72x divided by negative 8x. 3 terms, 3 fractions, all being divided by the same monomial, one term, monomial in the denominator. Okay? So when you see it in this, when you see your problems in this way, this is exactly what it is. That means every single term is going to be divided by this one term, okay, or maybe 2 terms in the denominator. All right. Let's take it one term at a time. But before we do that, let's do a quick review. If you guys remember, from your cheat sheet I gave you on exponent rules, in this case, we have the quotient rule. The quotient rule. And I believe that is spelled Q-O-U-T-I-E-T. It's probably wrong, but oh well, I'm not an English teacher. Okay, the quotient rule tells us if I have the same variable, I'm going to use A. If I have the same variable being raised to a power, in this case, I'm going to have M as a number, which is an exponent, and I'm going to have N as an exponent. Okay? Exponent powers are used interchangeably, same thing. If I have A raised to a power in the numerator, and A raised to a power in the denominator, because I have the same variable, this is A, that's A, because my variables are the same, I'm going to subtract my exponents. Now, remember, you subtract the exponent that's in the denominator, in this case are N, from the exponent that's in our numerator, M. So I'm subtracting N from M. Okay? Let's use a number so it makes it very clear. Let's say I had 2x raised to the power of 2 minus 2x. Notice, our variables are the same, x and x. Minus 2x, or excuse me, divided by 2x raised to the power of 1. Well, because I have the same variables, this would be 2x raised to the power of 2 minus 1. And that would equal, forget our 2 over 2. 2 divided by 2 is 1. So this will equal x raised to the power of 1 because 2 minus 1 is just 1. Okay? Now that we got that review done, let's work through this problem. All right. Don't forget your signs. A negative divided by a negative is a positive. So we know we're not going to have a negative once we're done dividing this. Negative 64 divided by negative 8 is positive 8. Okay? Then remember, we're going to subtract our exponents attached to the variable. This is 5. Even though there's no 1 here, technically this is 1 because anything raised to the power of 1 is itself. right? If I had 6 raised to the power 1, it's going to be 6. Because if you notice, I only have 1 6. If I have 6 raised to the power 2, this tells me I have 6 times 6. And if you notice, look, it matches up. I have 1, 2 6s. Same thing here. So 5 minus 1 is 4. So I'm going to have 8x raised to the power of 4. Let's go to our next term. Now remember, a positive divided by a negative is a negative. Okay? So I already know I'm going to have a negative answer when I divide these out. When I divide 32 by negative 8. Okay? Positive 32 divided by negative 8 is a positive 4. Okay? Now, remember, we subtract our exponents if the variables are the same. If the variables are the same. Well, they are. So I'm going to have 4 minus 1. 4 minus 1 is 3. So I'm going to end up with x raised to the power of 3. Okay, I'll go over it again. Our variables are the same, x and x. So because they are the same, I can subtract our exponents. Remember, you subtract the exponent that's in the denominator from the exponent that's in the numerator. All right, let's go to our next one. A negative divided by a negative is a positive. So we already know I'm going to have a positive answer when I'm done. Okay, so negative 72 divided by negative 8 is positive, which I have right here is positive 9. Okay, now let's not get tricked up by this one. 1 minus 1. Remember, this is x raised to the power 1 divided by x to the power 1. So we're going to have 1 minus 1. 1 minus 1 is 0. Okay, now if we recall, anything raised to the 0 power is just going to be 1. And think about it. This tells me that I'm not going to have this variable anymore because there's nothing there. But I need a placeholder, right? I need a placeholder. Because technically this x, we don't know if x is 0. So to have a placeholder, we're just going to put 1. Okay, if I have 6 to the 0 power, that means I don't have 6 here anymore, right? But I do have a base. I have one base. So because I have that one base, I'm going to have it as a placeholder. Representing that I just had that one base. Or that's 6. Okay, remember your base is whatever's been raised to a power. The large number is your base. This is your power or your exponent. All right, so that means I will have 9 times 1 because x raised to the power 1 minus 1 is 0. And anything raised to the 0 power is 1. So I'm going to have 1 times 9. 9 times 1 is just 9. And that is our answer. That's it. We are finished. Now, we have one other problem I want to go over. We won't worry about long division right now, okay? I have one more problem I want to go over. So let's add a new page. On the back of your paper, I want you to write dividing or divide using inverse law. Okay? Divide using inverse law. All right. On your paper, on the back of your note sheet, I want you to write 3x raised to the power 4 times y squared minus 4x raised to the power of 3 y to the third plus 12x raised to the power of 2 times y to the fourth. All that's going to be in parentheses. All of this, everything in this parentheses is going to be divided by 3x y to the second. Okay, remember, when you're doing long division, whatever's on the left side of the division sign goes underneath the box. So all this would go here. And then this on the right side of the division sign, on the right side would go here on the outside, okay? But we're not going to worry about doing that. But if we had to do that long division, that's how we write it. So, inverse. The inverse means to invert something, to flip it, okay? So to flip it, this would go, the number in the denominator would go to the top, and the number in the bottom would go, the number in the numerator would go to the denominator. Okay? Now, before we go any further, remember, this whole thing is technically, this can be a fraction. Anytime you have a number in the numerator, we can make it a fraction by just putting 1 underneath it. Okay? So, this whole entire expression, even with the 1, is going to be divided by this. Well, remember, anytime we're dividing two fractions, okay, I'm going to teach it this way. You keep the first fraction. So 1, keep first fraction the same. So when we say keep, it means keep the first fraction. So keep first. Second step, let me put a 2. Second, you change the operation. You change the operation. Okay, our operation is division. So in this case, we're going to change our operation. Change operation, which is division, to multiplication. Now let's put these in different colors. Change division to multiplication. Then, our third step, we flip the second fraction. So flip second fraction. And let's smooth that over so you can see a little better. Flip second fraction. Let's rewrite that. Have more room. Flip second fraction. Okay, our second fraction is this. Okay, now let's write it in a way that you guys are probably more used to seeing it. Okay, so now I'm going to rewrite this. I'm going to rewrite 3x to the power 4 y second minus 4x power 3 times y to the power 3 plus 12x squared times y to the 4th. Remember, all of this, put in parentheses, is going to be divided by. All right, so we kept the first fraction. Oh, I forgot something. I messed up. We kept the first fraction. We did step 1. Bam, done. Second step, we got to change our operation. We're not dividing. We got to change it to multiplication. So I'm going to put x here. Actually, let's do purple. Complementing colors. We got to change it to multiplication. So this is an x this means multiplication. And we'll put, we'll put a dot. So we'll have that here. This x means multiplication. We'll put a dot. Then, so we done our second step. Bam, that's done. Last step. We got to flip our fraction. Our fraction is this, 3xy over 2. So now we're going to have 2 over 3xy. Okay, we inverted it. Those of y'all that play video games, Call of Duty, airplane games, flight simulators, okay? They ask you, hey, do you want to keep the controls the same when you go to options when you first start playing the game? Do you want to invert the controls? Where if you pan down, your camera will tilt up. And if you pan up, your camera will tilt down when you use your joystick. Okay, so we're inverting. Inverting, that's why it's called inverse. We're inverting our fraction. Okay, now remember, our first term or expression, our trinomial, right? Because we have 1, 2, 3 terms. This is technically a fraction, right? I put a 1 underneath in the denominator, it's a fraction now. Now we just multiply straight across. Okay, straight across. So now, when I rewrite this, remember, if I have 3 terms, that means I'm going to have 3 fractions. But first, we have to multiply. Okay, so let's do that one step at a time. So now I'm going to have 2 times 3. Okay, so 2 times 3 is 6. We don't have any variables here attached to this 2. There's no variables, nothing there. So because there's no variables to multiply, we're just going to tag on the variables that we have right here. So it's just going to come down. X to the 4th, that comes down. Y to the 2nd, it's just going to be the same because there's no other variables here. There's nothing there. All right, we'll go to the next one. We know a negative times a positive. Our 2 is positive. I'll put a plus on there. And we have a negative, so a negative times a positive is negative. So we already know we're going to have a negative answer. So negative 2 times, positive 2 times negative 4 is negative 8. So I have my negative sign. Again, we have no variables to change, so it's just going to be x to the power of 3, y to the power of 3. Okay? All right, our next sign. We have a positive times a positive. Well, guess what? Positive times a positive is more positive. So you know I'm going to have a plus right here. Okay? Now I have 12 times 2. So 12 times 2 is 24. Again, there's no variables to multiply and add the exponent, so we're just going to bring down those same variables, just like we did here. Same variables, okay? So now I'm going to have x squared and y to the 4th. All right, now we just multiply whatever we have in the denominator, which is our 1. Let's get rid of these so it makes it more clear. So now we're just going to have 1 times 3xy. Well, guess what? Remember, every single term, this term, that term, this term is all going to be divided by 3xy. So I should have 3 fractions. Okay? So now I'm going to have this divided by 3xy, that divided by 3xy, this divided by 3xy. Okay? All right, let's take it one step at a time. 6 divided by 3 is 2. It's a whole number, so we don't have anything left in the denominator. Remember, our exponent or quotient rule with the exponents when dividing with variables that have the same, when dividing with exponents that have the same variable, you subtract the exponent that's in the denominator from the exponent that's in the numerator. Okay, so 4 minus 1 is 3. So I'm going to have to the power of 3 for my x. 2 minus 1 is just 1. You don't have to put a 1 here because why? Anything raised to the first power, again, it's just going to be that base. My base is y. It's raised to the first power, and if you notice, only have one y. Okay? So that's what we're left with. So I'm not going to worry about putting a 1 there. Okay? Now, 8 divided by 3, or negative 8 divided by 3 is not a whole number. If you put that in the calculator, it's not a whole number. So, for the sake of aesthetics, meaning the way it looks, without problem, we're just going to leave it as 8 over 3. Okay, and that's acceptable. This is what we call exact. This is exact formation. Okay, this is more exact than giving a fraction, or a decimal answer. Okay, so we have 8 over 3. Now, remember we have 3 minus 1. Even though there's no 1 there, technically there is. 3 minus 1 is going to be 2. It's going to be in our numerator. Okay, our x is going to be in our numerator, and the reason why is because we're left with a positive answer when we subtract these exponents. Okay, so we're going to have x to the second power. And it goes in the numerator up top with the 8 because it's a positive exponent. If we had a negative exponent, then we could put it down here, our variable with the exponent down here. But because it's positive, it's going to go in the numerator. 3 minus 1 for our y. 3 minus 1. Let me erase that so it looks more clear. 3 minus 1 is 2, so we're just going to have y squared. Let's go to our next term. We have a positive here. This 3 is positive, so we know we're going to have a positive answer because a positive divided by a positive is a positive answer. Okay, 24 divided by 3 is 8. We got to finish our exponents. We have 2 minus 1. 2 minus 1 is just 1. So now I'm just going to have x. And the reason why I'm just putting x because, remember, anything raised to the first power is just going to be itself. Okay, there's no need to put a 1 there. It's kind of redundant. So I'm not going to worry about putting a 1. All right, and you got to get used to seeing that when you guys do your tests because you will have it that way. They expect you to know that. All right, now we have 4 minus 1. Okay, 4 minus 1 is 3. So my y is going to be raised to the third power. And that's it. We are done. We divided everything. We subtracted all our exponents. Okay, and that's it. And just to go back over through the steps again, when dividing polynomials or dividing any fractions, when you're dividing 2 fractions, remember, you keep the first fraction. We did that. We kept the first fraction the same. Everything looks the same here. Even if there's no 1 there, technically it's still whatever your expression is in the numerator over 1, okay? So we kept the first fraction. We changed the operation. We went from division to multiplication, which we have right here. That's what this dot represents. And then we flipped our second fraction, right? We started out with 3x over y, but now it's 2 over 3xy. We inverted it for you video game players, okay? Then we multiply straight across. We didn't cross multiply, we multiplied straight across. All right, and then we carried out our division. We multiplied straight across. That's how we got our 6, -8, our positive 24. Then we divided each of these terms, okay, by what we have in our denominator, which is our 3xy. And we subtracted our exponents. Okay? Hope that helps. Please study.